All right, so here we are in 7.3 Day 2 washers. And I just want to say that I think that this lesson is as easy as pie. And speaking of pie, I don't know if I really stress it enough, but it's really important that you don't forget about it. So to help you to not forget about it, I thought, a couple jokes might be, something good to help you with remembering this. So the first joke is, I bought this DVD, and when I looked it up online, it had been rated 3.14 stars. I think it was pie rated. Get it? Pie rated. All right, the next one. I don't know if you heard about the pie that walked into a bar, and the bartender says, "Sorry, we don't serve food." Get it? They don't serve food. And then the last one, not sure if it's the best because these are all good quality jokes. What is a ghost's favorite pie? Blueberry pie with ice cream. All right, so I hope you enjoyed those, and we are for sure not going to forget about it when it comes to discs and washers. So here we go. We are going to graph the function y is equal to x squared and y is equal to 2x. We're going to get a contained region, and then we are going to go ahead and reflect that around the line y is equal to x. The line x is equal to 2. So I'm going to draw that. All right, so we have the two functions graphed. Y is equal to x squared and y is equal to 2x. Pretty easy functions. We've got the contained region drawn in yellow, and they tell us that we're revolving it about the line x is equal to 2, so that's a vertical line. So all of that is noted in the diagram. Now, I can show what it spun and what that looks like, so I can draw that too. So it looks somewhat like a comb because the sides are linear, and then I have that curved inner wall to it. And so when I take slices, for sure we're going to get washers. So what I'm going to do is just on my original drawing, I'm going to draw in. So from the axis of revolution, the first thing that I hit is little r. That's going to be from here to there. That's going to be little r. And then I'm going to draw in the segment that's going to show what the big radius is. So I'll do that in blue. So from the axis of revolution to the outer containment of the region, that's big R. So on my 3D, that right there would be big R. So once you have that labeled, it's really as easy as just knowing our format and plugging everything in. So I'm going to put the pie. I'm going to make it the size of Omaha. I'm going to be looking at my slices. So my radius is perpendicular to the y. So that means I need to have both functions in terms of y. So I can see that I go as low as 0 for y, and I go as high as 4 for y. So that's going to bank me a point on the AP exam by having the right bounds and the right constant in front. All right, so I have solved for each of the equations in terms of x and terms of y, and now I'm ready to do my format for big R squared minus little r squared. Again, to get the length of a segment going sideways, it's important that I take the right minus the left, parentheses, squared, minus, to get little r, I'm going to get the right minus the left, and I'll square that. So it's really that easy. So if you want to write those notations above your integram, that will help you with putting all the pieces into the right place. And believe me, there's a lot of students that don't know how to do this correctly. But we're gonna make this as easy as pie. So for the big radius, what's on the right in terms of y? I'm going to be going from 2 is on the right, minus going to the left is my linear function, so that would be y over 2. And I'm going to do little r, same thing. What's on the right is 2 minus what's on the left is the curve, which is root y. Now again, don't forget about your differential, so I'm going to tuck that in right here on the right hand side. And usually that's the extent of what they do with the washer method. They usually have you use your calculator to compute the value. So again, just don't forget the pi. That's really important to type that in as you put that in your graphing calculator. When you do that, you should get 8/3 pi. All right, so we've got quite the deal for you. Today I have a pi 1, get 1 free special. So we did the first one. Here's your bonus. This is your freebie. So in the last example, I've drawn in the same function. They just tell me that we're spinning about the y-axis. So again, because I have gapage between the contained region and the axis of revolution, when I spin that around the y-axis, there's going to be slices that have these holes in the center. So I'm going to go ahead and label from the axis of revolution, the first thing that I hit is little r. From the axis of revolution to the furthest thing that I hit, that is big R. Now again, I can draw this, and it's going to be kind of bowl shaped on the outside. I'm spinning it around, but the side walls are going to be coming up like this. So it's almost like a cone inside, but yet it's a bowl on the outside. So there's my shape. We are going to find the volume, and again, easy as pie. So here we go. I'm going to need a integral. And of course I need pi because the area of a circle is pi r squared. My slices are perpendicular to y, just like in the previous example. So I want everything in terms of y. Y is equal to 0 up to y is equal to 4. Great. So big R squared minus little r squared. I'm going to take the right minus the left squared minus the right minus the left squared. This is going to be our format. So we're going to do that right here. What's nice about this is what's on the left is simply the y-axis, which means that all the y values are 0 there. So I'm going to go ahead and do that. So big R squared is that longer segment that's going out to the curve. The curve is the root of y. We're going to go ahead and square that. Minus little r squared. So again, that's the red segment. That is the linear segment. That is y over 2. I'm going to tuck in my differential dy. And that is my setup, folks. So we looked at different examples where we're rotating either on an axis or on something that's parallel to the x or y axis. And there's our format right there. So I hope this video was helpful. Do the problems that are listed at the bottom of the notes. Practice a couple every day. And we will talk Monday about calculus being like a box of chocolates. So I'm going to go ahead and enjoy that delicious, hot apple pie with ice cream. And, you know, pie is a terrible thing to waste. So hope your weekend's great. We'll see you next time.